sir, looks like we're at it again, building roads. Building new roads to take care of a new generation of Americans and the millions of new cars and trucks that are pouring off the assembly lines every year. Sort of makes me feel like I've been here before. Take old Stanley over there. Stanley and me, we've seen a lot of roads built in our time. Seems like only yesterday they were building those farm-to-market roads in the 20s. Yep, we needed roads then too. Folks finally decided the gas buggy was here to stay, and they put old Dobbin out to pasture. This is how the old road to Centerville looked in the 1920s. Not much more than a grown-up wagon track. Made to order for Dobbin, but sure was tough on Stanley. So they paved the road to Centerville, if you could call it a pavement. Just a thin skin of asphalt covered with sand and crushed rock. But to us folks who traveled that road, it was a superhighway. No more dust, and it shed the spring rains like water running off a duck's back. It took a lot of patching, but it kept America's wheels turning. And here's the important point. It gave us the roads we needed at a price we could afford to pay. Fact is, a lot of those old blacktop roads are still in business today. Most of them have been built up with a simple facelifting, what some engineers call seal coating or surface treatment. What it amounts to is this. Any damage on the surface being paved is repaired. Then liquid asphalt is applied to the road surface. And another cover of sand, crushed stone, slag, or gravel aggregate is spread and rolled. A lot of our so-called blacktop roads have been built up like this year after year to carry the increasing load of traffic. And dollar for dollar, they proved the greatest road bargain in history. Well, the trouble was, those old blacktop roads of yesterday created their own special problem. With thousands of miles of these low-cost, hard-surfaced roads, America began to move. The new cars grew faster. The trucks were bigger and heavier. Before long, congestion set in, and we just plain outgrew those old wagon tracks and thin pavements. But in the meantime, asphalt technology wasn't standing still either. In the laboratories, like this one at the Asphalt Institute on the campus of the University of Maryland, the research engineers were steadily testing and improving the quality of the paving mixtures. Other advances were being made outside the laboratory. This mechanical asphalt spreader came along in the 30s. Now, the carefully controlled mixtures of hot asphaltic concrete could be fed into these machines and spread in smooth, even layers. And so, after World War II, when new roads were being planned and the road builders needed a heavy-duty pavement that could be laid swiftly and economically, the asphalt technologists were ready with a modern asphalt pavement. Trouble was, people still thought of asphalt as the old blacktop, just a thin, makeshift sort of a pavement. Good enough for country roads, but not quite rugged enough for the new expressways the nation was crying for. Folks didn't seem to understand the difference between two pavements that looked pretty much alike. On the surface, that is. But the engineers knew the difference all right. And the mileage of heavy-duty asphalt pavement jumped from 68,000 miles in 1945 to nearly 200,000 miles in 1955. The road building revolution had begun. It all got started down in the state of Maine. In 1947, those Maine folks built themselves a 47-mile asphalt turnpike from the New Hampshire line all the way into Portland. It was built fast, and like other asphalt roads, at low cost. But the important thing, it was built to take a lot of punishment. And it has, too. In a climate that's even tougher on a road than heavy traffic. Folks down Maine were so pleased with their asphalt turnpike, they later added another 66 miles and extended it all the way to Augusta. Meanwhile, in 1949, New Hampshire tacked 14 miles of asphalt turnpike onto the southern end of the Maine Turnpike, carrying it across to Massachusetts. Since then, they've been building 63 more miles of asphalt toll roads. Guess folks in New Hampshire are satisfied. Shucks, it's no wonder they liked their first heavy-duty asphalt expressway. In its first 5 years of operating, it cost an unbelievably low $36 a mile for maintenance and carried more than 14 million vehicles. But the turnpike that really convinced the skeptics was the New Jersey Turnpike. Built in just 2 construction seasons, this bread-and-butter turnpike opened in 1952. In its first 5 years, the New Jersey Turnpike carried well over 100 million automobiles, buses, and heavy trucks. By 1955, it was carrying more than 31 million vehicles a year. More traffic than was expected in 1979. Why, in 1955, they had to add a couple of extra lanes to handle the traffic. This asphalt paved road has taken the worst beating that modern traffic can hand out, and it's still as sound as the day it was built. Well, these early turnpikes inspired others. When Oklahoma opened its Turner Turnpike from Tulsa to Oklahoma City, its entire 88 miles were paved with asphalt. Yep, and Oklahoma was so pleased with its Turner Turnpike that it decided to extend it another 88 miles to the Missouri line. And back there in New Jersey, the beautiful Garden State Parkway, with the best safety record of all the toll roads, was built as an asphalt highway all the way from the crowded cities of North Jersey to the famous resort towns of the Jersey coast. 145 miles of it. Early in 1957, Florida opened the first leg of her brand new Sunshine State Parkway from Miami to Fort Pierce. Eventually, this asphalt expressway will swing up through the center of the state to the Georgia line, 278 miles away. Massachusetts, Connecticut, and Virginia are running up the score. Now, maybe you're wondering just why so many highway engineers and turnpike authorities wanted this modern asphalt pavement for their toll roads. Well, the Kansas Turnpike is a typical project. Let's look in and see how a modern asphalt highway is built. This will show you the difference between the old surface-treated blacktop road and the carefully engineered flexible pavement of today, built from the ground up. First, the engineers studied the climate and terrain. They made rainfall, frost, and snowfall studies. Samples were taken of the typical soils they would encounter along the route of the turnpike. Armed with all this information, they drew up their design for the 181 miles of asphalt pavement, the section from Topeka, Kansas to the Oklahoma state line. Now, they figured this pavement ought to start with 10 inches of granular subbase. This would give the road a sound foundation, good drainage, and frost-free. On top of that, wet 8 inches of granular base, with 2.5 inches of asphaltic concrete, called the binder course, over that. And finished off with 1.5 inches of asphaltic concrete surface. An overall pavement thickness of 22 inches. 4 inches of smooth, rugged asphaltic concrete on 18 inches of base and subbase. That's the secret of any good, durable pavement. A sound base with good drainage. And as you will see, these modern asphalt roads are carefully engineered right down to the basement. The first step in the actual construction of the road was the grading and compaction of the subgrade, or native soil. To bring this native soil to correct density, 50-ton rollers were used on the entire subgrade. While this was being done, samples were taken of the major soil types and combinations. All the standard tests were run, over and over again, to find out things like the optimum moisture content of the soils, their liquid limit and plastic limit, and the standard density. These tests, like this soil liquid limit test, told the engineers exactly what to expect from the subgrade, and consequently, what to do about it. When the subgrade was in place, 3 passes were made with a heavy pneumatic roller. Areas which rutted or sponged were carefully inspected. Unsatisfactory material was replaced, and the section rolled again. With the subgrade or native soil prepared, construction of the pavement itself began by depositing the subbase materials. These materials were separated into 2 sizes and deposited separately in windrows like these. Coarse materials in one row, fine materials in another. Then the 2 windrows were mixed by these blades until tests showed a uniform mixture ready for spreading. Now the mixed materials were spread evenly on the subgrade, then watered down to provide the necessary moisture for good compaction, and rolled, either with pneumatic tired or vibratory compactors. The 10 inches of subbase were built in 3 separate lifts. The 8 inches of base construction, which came next, were placed in 2 4-inch layers. On some sections, mechanical spreaders were used to lay the subbase and base materials. Where this was done, the materials arrived at the road site pre-mixed to uniformity. With mechanical spreaders, some base materials were laid in layers thicker than 4 inches. Where this method was used, the materials were compacted with pneumatic tired rollers, along with vibrating compactors, such as these vibrating steel wheel rollers. The finished base course was allowed to cure until an acceptable moisture content was reached, and mechanical brooms swept the base to remove loose particles. Then the base was primed with a medium curing liquid asphalt. The primed base was allowed adequate time for curing before paving began. The 4-inch asphaltic concrete pavement then was laid in 2 courses. The 2.5-inch binder course, followed by 1 1/2 inches of surface course. These paving mixes were carefully proportioned and prepared in modern hot mix plants. Then transported, still hot, to the roadside, where they were spread by finishing machines into a smooth, partially compacted mat of uniform thickness. The final operation was the rolling, and one of the most important phases of the construction. On the Kansas Turnpike, compaction was done in 3 distinct stages. First came the breakdown rolling. This was begun as soon after the mix was spread as possible without causing displacement of the hot pavement mix. The second rolling was made with self-propelled pneumatic tired rollers, while the mix was still warm and slightly plastic. The final rolling was done with a 12 to 15 ton 3-axle tandem roller. This rolling was continued until the required density was obtained. Then the roadway was checked for smoothness. Not a depression in that 181-mile carpet of asphalt pavement deeper than 3/16 of an inch. Bet the legendary magic carpet never gave a smoother ride than this modern pavement. Well, finally came the paving of the shoulders. 4 feet onto the inside lane, a margin of safety for passing, and 10 feet on the outside. Plenty of room to pull safely off the roadway in case of a breakdown. These fully paved shoulders give added support to the traffic pavement and added safety to the driver. And there's the finished turnpike, a far cry from the old blacktop road. Designed for speeds of 70 to 75 miles an hour, the sharpest curve is a sweeping 3 degrees, and the steepest hill an easy 3% grade. That's the story of every one of our modern asphalt expressways. Easy on the budget, long-lasting, safe, and traveling on them is like cruising in a dream. Yep, Stanley and me, we got a lot of miles of pleasure driving ahead, and we expect to do most of it on modern asphalt highways, turnpike-tested ribbons of velvet smoothness.